why my favorite incorrect answer was what most kids put. We had a lot of kids that did this yesterday. They said, all right, I'm looking at, and it appears to me like it's a piece of watermelon. And how fitting. I'm excited to actually have fresh watermelon fairly soon. Okay? And it's a nice day today. We're supposed to be. I did go outside a little bit for lunch, but it was a little bit chillier than I expected. I'm hoping it gets warmer. I hope so. Okay? Here's what kids did with this. They saw that the measure of this angle right here was 45 degrees. And they said, well, if this is X and this is X, I know that the measure of all three angles of a triangle has to be 180. So I saw over 90% of the kids do 180, subtract 45, and they ended up with an answer of 135. Now here's where kids did this incorrectly. They said that X is equal to 135. So my question to you is, what's my error? What did we do wrong? How can we fix this? Because according to what we have, we say that this is 135, this is 135, and this is 45. Okay? So what's my error? Can I show? She's exactly right. We know that 180 degrees is equal to all three of the angles. So what Emma's saying is it's 45 plus X plus X. And she combined them and said, you know what? That's really just 2X. So it's 45 plus 2X is equal to 180. Well, if we're going to do this algebraically, which, look at this. This is an algebraic equation. It has a variable in it. If we're going to do that, we have to discount our 45, which, as I said yesterday, I saw over 90% of the students do this. Now, of that 90%, I would say close to half of those kids that got 135 answered the question as 135 degrees. Then the rest of the kids were actually able to answer the question correctly. Okay? So we end up with 135 is equal to 2x. And do you notice how it says solve for just x, not solve for 2x, solve for x. So we have to divide by 2. Now, I didn't see one kid that set up their problem like I have it up on the board. But does everybody understand how we could set this up like this? Many of the kids did these steps, and the kids that got it right subtracted 45 and then divided 135 by 2. Okay, so I'm going to just do that right here. 135 divided by 2. How many groups of 2 will go into 130? And that would be 60, right? 60 times 2 is 120. And I have 15 left over. How many groups of 2 will go into 15? 7. And that's 14 times with 1 left over. Okay? Now, if we remember, we used to call this a remainder. Now we can call it the numerator of our fraction. And the number we're dividing by becomes the denominator. So it ends up being 67 1/2. If we wanted to find a decimal, we would just go like this. I'm going to just erase that right now. Whoops, I accidentally hit an extra button here. Let me get that out of here. Then all I do is put in my decimal point, add a 0, bring it down, and how many groups of 2 will go into 10? 5, and that's why we'd have put up our decimal, put the 5 there. We have 67 5/10. That's what 1x is equal to. And here's why we know. Both of these have to be the same. One, they're both equal to x. But this is a key piece of information right here and right here. If we have two congruent sides on a triangle, we have to have two congruent angles. If we have three congruent sides, like an equilateral triangle is, we have to have three congruent angles, which is 60 degrees for each of them. Every single equilateral triangle, the measure of the angles will be 60 degrees. We okay with that? All right. Now, we're going to move into the last two lessons today of our geometry unit that we've been doing. We will cover benchmark 6331, which has to do with converting measurements, both customary and metric. So we're going to have to remember our King Henry died by drinking chocolate milk. Okay. Yes, we'll make some good connections to science. We also have to know those customary measurement conversions. So just so everybody knows, on our test that we're going to take on Monday, I will allow you to make one sheet of paper that has information on those conversions. If you want to write King Henry and the steps that we make for King Henry died by drinking chocolate milk, and you can put in those kilos and decas and hectos and the base unit, all those different steps, you can put that on there. But then if you also want to do customary measurements like inches, feet, yards, miles, and those conversions. If you want to do the capacity measurements of ounces and is it ounces, cups, pints, quarts, gallons. And then if you want to do the mass measurement of ounces, pounds, tons, you can have that all on a sheet of paper and be able to use that for your test. That'll be enough of that. Yes, ma'am. You can. And I'll tell you right now, one of the best places to do it, there's a page that's in your planner that has every one of those conversions. In fact, it even converts between metric and customary. Okay? Now, on your MCAs, you're going to have to know. You're going to have to know how many quarts are in a gallon. There's 4 quarts to 1 gallon. You're going to have to know how many pints are in a quart, how many pints are in a gallon, and so on and so forth. Okay? And you'll definitely need to know that for your test. So, what I'm going to ask you to do is pull out your planner right now, and we're going to work through these problems together. I don't remember the exact page, but I think it's in the front of your planner. Page 5 has the conversions. Thank you.
The colored page 5?
Colored page 5, yes. So, we're going to go from very basic level questions, and we're going to build our way up to the more challenging ones of these. So right here, we can see that we have 3 gallons, right? How many gallons of juice did Sarah buy? Well, 3 gallons. Let's go. Sarah bought drinks for a friend. She brought 3 cartons of juice. How many quarts of juice did Sarah buy? And based off your conversions, what I need to know is how many quarts to gallons. Okay, I'm going to use ratios to show this. How many quarts to 1 gallon? Yep. Look in your sheet. It's 4 quarts to 1 gallon. Everybody agree? We call that a unit rate because it's how much for one. So I know right now I have 4 quarts here, 4 quarts here, and 4 quarts here. We can either repeatedly add 4 plus 4 plus 4, or we can do what? Times what? 4 times 3, because we know that multiplication is repeated addition. Okay? So if I have a grand total of 3 gallons, everybody remember this rule? Whatever we do to the bottom, we multiplied by 3. We have to do to the top. And look at that. 4 times 3 equals 12. 12 quarts. Everybody see that? Okay, you should have this written down in your notebook. If we write down, this is going to help us to remember how many quarts there are to a gallon. I'll give you a second to write that down. Everybody have that copy down? Okay, 4 quarts to 1 gallon. If we have 3 gallons, we multiplied by 3 on the bottom, 3 on the top. Many of you just automatically would just do 4 times 3. But this is mathematically why it works. We have a ratio. Actually, it's a rate. 4 quarts to 1 gallon. Okay. Here's question number 2. Nancy needs to buy 5 yards of fabric to make her costume. These are the pieces of fabric she sees at the store. Which piece of fabric should Nancy buy? Should she buy 3 feet or 15 feet? Shh. Look at your conversion. Write down your unit rate that you need. What is the unit rate conversion that we have to use? What's the unit rate conversion that we should use? Feet to yards, right? Feet to yards. How many feet are in a yard? 3 feet is 1 yard. Okay? Now we have a grand total of 5 yards. So how many feet? If we do it, it is 15 feet is 3 yards. So we needed that one. Everybody have that? 3 feet to 1 yard. That's one everybody should have memorized already. Okay? All right, here's the next question. Paul needs a 10-pound bag of food for his cats. These are the bags that he sees at the store. Which bag of food should Paul buy? So this one, it doesn't matter how many cats. He just needs a 10-pound bag. We have 60 ounces, 160 ounces, 16 ounces, or 80 ounces. I'll give you some time. Look at your chart. Write down that unit rate. Okay, what unit rate should we use? What unit rate should we use? Yes, you. We're comparing ounces and pounds, right? So how many ounces are there to 1 pound? So 16 ounces is the same thing as 1 pound. Now we know that we need to find how many pounds? We need to get 10 pounds. So that means we need to take 16 and multiply it by 10. Because 1 times 10 is 10. So 16 times 10 is 160 ounces. That means we need to do this one here.
Yes.
Okay? And I make sure you're copying down those unit rates. 16 ounces per pound. That will help us out when eventually we get to the MCAs. And I'm hoping that when we copy down and make our little sheet for that test, that as you copy it down, that will help you. All right, here's the next. All right, need to know the unit rate. Need to know the unit rate. What unit rate should we use? What are we comparing? We're trying to find what? Okay, we're feet to yards, right? So I'm going to compare feet to yards. And we've already used this one before. How many feet are in a yard?
3.
3 feet is 1 yard. Now, how many yards do we have here?
4.
We have 4 yards. How many feet do we have?
1.
How many?
4. 3 times 4 is 12.
It should be 12 feet. Times 4 here.
Times 4 there.
Times 4 here. Whatever you do to the top, you have to do the bottom. Okay? We ready for the next one? Now, it's difficult to see, but there is. If you look at the handles, there's 1 bag, 2, 3, 4. There's 5 bags in here, okay? Bob did buy 5 bags of rocks for the bottom of his fish tank. How many ounces of rocks did Bob buy together? What unit rate do we need to know? What unit rate do we... What unit rate? Ounces to pounds. Very good. How many ounces are in 1 pound? "16 ounces is 1 pound. How many pounds do we have here? 5 pounds. How many ounces is that?
80.
80. Now, we multiplied by 5 here, multiplied by 5 here. I'm going to use the distributive property. What's 5 times 10?
50.
50. And then we're going to add that to 5 times 6.
30. 80.
What's 50 plus 30?
80.
We should have 80 ounces.
Kindergarten method. I think it's the kindergarten method.
Okay. Next question. Ooh, our very first King Henry. It's our very first King Henry. Okay, so here's what I would encourage everybody to do on your sheet of paper that you'll get for your test. You probably want to write, and I'll, King Henry died by drinking chocolate milk. And then I believe your science teachers actually build the steps. Is that right? And so when we go through here, we know that this M stands for millimeters. This is millimeters. Okay? The C stands for centimeters. The D is, this is, I believe, this is decimeters. The B stands for base, and that base depends on which unit of measure we're using. Either meters if we're talking distance, liters if you're filling up like capacity,
Or the grams.
okay, or grams if we're measuring mass. Then we have deca, hecto, and kilo. And every step means that we need 10. So let's start. It says, last week Harry walked his dog 4 days at a nearby park. Each day they walked on a trail 2,400 meters long. How many kilometers did they walk at the park last week? What's our first step? What's the first thing we need to do? And it might vary. Yeah.
Okay. First you need to do is you have to do 2,400 times 4.
Okay, explain why it's 2,400 times 4.
2,400 each day. She walks, stop,
Yeah.
and
Did you know that's a unit rate? 2,400 meters per day. We're comparing two different units. That is a unit rate. Okay, we want to figure out how much for 4. Okay, and what'd you get for an answer?
I got 9,000.
I'm going to go 4 times 2,000 is 8,000. 4 groups of 400 will give me another 1,600 or 1,600. And we have 9,600 meters. Now, our meters, and I would write, thank you. If I were you on your King Henry chart, I would write next to my base, I would say either meters, liters, or grams. And we are going down to this piece right here. Okay? And I see that we're going to move 1, 2, 3 steps. So we take that 9,600 meters and we go like this and we move our decimal. Because we moved our decimal to the left 3 spots, or we went down to the left 3 spots, we have to move our decimal 3 spots. And that will equal 9.6 kilometers. And that should make sense, because if you want to know the actual way to use this, I know that there are 1,000 meters for every kilometer. And we know that we have 9,600 meters. How many kilometers do we have? Well, for each 1,000 we have 1, right? Does everybody see that with 9,600 we have at least 9 kilometers? Then we have this 600 left. We only have 600 out of 1,000. That looks like this. 600 out of 1,000. When we reduce that fraction, we can just start saying, all right, I'm going to divide by 10. That's what I'd have left. If I divided by another 10, that's what I'd have left. When we reduce that, we have 6/10. Does anybody know how to write 6/10 as a decimal? 6/10 as a decimal? Yeah. How do you write it?
Oh, I think you said how to say it. I'm like 6 cents. It was 0.6.
0.6. So we would have 9.6 kilometers. Everybody okay with that? So this is, eventually this is the way you should be doing it. But for right now, there's nothing wrong with using your King Henry. Okay? But we should understand that we're still using unit rates of 1,000 meters is 1 kilometer. Okay? We have 9,600 meters. That means we have 9.6 kilometers. Okay, we'll move on to the next question. So he explained that we need to find feet per mile. Noah, how many feet are in a mile? 5,280 feet for every 1 mile. Now, how many feet? We're traveling at how many feet? 31,750 feet. We need to figure out how many miles. Who can tell me, how can we solve this problem? And I'll give you a hint. You want to know how many 5,280s will go into 31,750. So what math problem should we use? Yeah. Division. What two numbers do we need to divide? Oh, if you do that, you're going to be off, my friend. Yep. Everybody agree? Now, how many 5,280s will go into 31? I'm going to guess right now it's probably pretty close to 6. Is that right? Because I know that 6 times 5,000 is going to be around 30,000. Okay? And it says approximately. So guess what we're doing right now? We just moved into 6332. And that's using estimation with conversions. Okay? So this answer, because I know that 6 groups of 5,200, 6 groups of 5,000 is 30,000. I'm going to say that this is about 6 miles. Did anybody do the math? Did anybody punch this into their calculator? 31,750 divided by 5,280? We have Coca-Cola working on it right now. I just see a Coca-Cola calculator. Actually, that's probably a phone that's calculator. 6.01. Would you say that that's approximately or about 6 miles? Perfect. Any questions on that? You should know on your sheet for Monday's test, you should copy down how many feet are in a mile and how many yards are in a mile. Can anybody tell me, how would we find how many yards are in a mile? Go ahead. Yeah. Divide what by 3? Yeah. If you did 5,280 and you divided it by 3, this is the feet in the mile. This is how many feet are in a yard. You'll know that there's 1,760, and yes, it says it right in your book, but 1,760 yards for 1 mile. For 1 miles. All right, here's our next question. Okay. What unit rate do we need to know to solve this problem? How about pounds to tons? Okay. Pounds to tons. How many pounds are equivalent to 1 ton? And so it's 2,000 pounds is 1 ton. Now we have 10.8 tons. So I'm going to do this, and we should still be able to see it. I'm going to write it again over here. Maybe we can't. 2,000 pounds for 1 ton. Everybody should have that written down. We have a grand total of 10.8 tons. So we'd have to take 2,000 times 10.8. Okay? What is 2,000 times 10.8? 21,600. Now, That will tell us how many pounds we have. But the question is, how many bags do we need? And so we need to take this 21,600 and divide it by 60, which equals about 360 or exactly 360. Okay? So we needed 360 bags. Everybody see why this is a little bit more challenging question? They didn't just want the total number of pounds. We had to then convert and say
Each bag.
how many bags if each bag weighs 60 pounds.
What's a unit rate?
Okay? All right. Here's what we know. Or here's what you need to know. What does perimeter mean? What is perimeter? Yeah. The length of each side put together.
Thank you.
Okay? So when we add up all the sides, we'll get the perimeter. Okay? So we know that the perimeter, or when we add up this side here, plus this side here, plus this side here, plus this side here, we should get 0.72 or 72 hundredths of a kilometer. Now maybe some of you might want to convert that to meters because we know that the length, we know that this is 160 meters and this is 160 meters. So one thing we might want to do is convert this to meters. 720 kilometers is how many meters? Did anybody do it this way? Did anybody convert this to meters? Or did you convert this to kilometers? If I convert 72 hundredths, how many meters is that equal to? It's equal to 720 meters. Because if I use my King Henry died by, and I just need to stop right there. We go like this and move our decimal 1, 2, 3 places because this is going to be my meters. That's the base. So I take 72 hundredths and move it 1, 2, 3 places and fill in that 0. I'll wait. The bell might be ringing at 1:45, but we won't be leaving if we continue to interrupt. And I will not rate you a pass. If you're late, that's your problem, not mine. And that it was recorded, by the way. Okay, if we have 720 total meters, our length is how many total meters put together? No, our length together is how many? 320? 160 plus 160 is 320. Yes. Now, what do we have to do with the 320 and the 720 to figure out what our widths are? Everybody agree we have to subtract the two? So if we take 720 and subtract 320, 320 is the total of the two widths together. We have 400 left over. That means that these two put together have to add up to 400. How many total meters is that? What is the width of one? Yeah. Yeah. 200 here and 200 here. Now, if we did this with kilometers, our answer would be 0.2, because 0.2 plus 0.2 plus 0.16 and 0.16, we should get a grand total of 72. let's see, 4, 5, 6, 7. So it'd be 0.2. Either 200 meters or 0.2 kilometers. Ooh, have fun with this one.